And so today we want to go over Module 2, and we're going to start with the measuring center and variation of data. No, we're not. I messed that up. We're going to start with measures of center and distribution. So, Skylar, I'm Heather.
I'm Skylar.
I'm Tony.
And here we go. So, Skylar, how do you find the range using this data?
So with the range, it's just the difference between the greatest and your lowest numbers. So with the Army recruits, their data, the greatest number looks to be 25.7 and the lowest number looks to be 14.1. So you would take 25.7 and subtract it by 14.1 and you get 11.6. And you do the same thing for the random mall shoppers BMIs, except for you would take within that data. So you use your own data for that one. Tony, could you discuss the correlation of standard deviations?
Yes. Okay. So the correlation between the standard deviation is, so for, it's 3.459 for the Army recruits and 17.094 for the mall shoppers. So the Army recruits standard deviation is actually a smaller amount away from each other, pretty much what that means. Like from the one BMI to the next BMI, it's only like 3.5 if you round. And the mall shoppers are 17.094, which could be 17.1, and their BMIs are going to be like farther apart from each other. So that's how the standard deviation works, is how closer each BMI is to each other, how far away they are. Heather, can you discuss the correlation between coefficients of variation, tightness of the data points about the trend lines, and heights of the box and whisker plots?
Yes. So when it comes to the coefficients of variations, it's just a small number, smaller numbers measured to make a more precise spread of data. So with the coefficient of variation, what you would do is you take the standard deviation of the set of data and subtract it by the mean. And so with the Army recruits, you take the 3.67, subtract 20.03, and you get 0.18. Again, it's just a smaller number for the spread of data. And then you look at the graph, and the little dotted line, that's your trend line, and you see that the points of data on the Army recruits are closer to the trend line than the ones of the mall shoppers. So the trend line itself just measures the spread of data. The reason the points are tighter with the Army data is because both the standard deviation and the coefficient of variation are small versus the mall shoppers, where the standard deviation and the coefficient variations are not as small. And last, we're going to scroll down and look at, this is the box and whisker plot. And if you look at the Army recruits, the whiskers, which are, we're just going to zoom in, the outsides of the box, the height of the whisker plot is going to be the height of the highest number you have on your data plot. So 25.7 is the height of the top whisker, and 14.1 is the height of the smallest whisker. And then your box, your height goes from the quartiles, so the quartile 1 and quartile 3, and then you have your median line as well. So since we have all of that, Skylar, can you tell me the likely reason for the differences in the spread of data?
Yes, so differences in the spread of data. So the Army recruits have a much closer spread of data. So like their data is a lot more closer to each other because they require a lower like BMI or just weight mass to be like in the Army, and they're only recruits, so they're not in just yet. And so they have to focus more on their BMIs and their weights and such. When somebody, if like it's just a random person, they don't have to focus as much because it doesn't affect their future career. Most people that they probably that they talked to in the mall, they probably already had their own jobs, so they weren't that focused about how their weight affects that. And so, like, if you look at the random mall shoppers, their BMIs are kind of just all over the place, while the Army recruits are pretty much very close together. That's
Interesting.
neat. Is that me?
Mhm.
Oh, discuss the probability of Army being with the Army recruits being within 1 standard deviation of the mean.
Okay, so with the standard deviation being smaller, the spread out of the BMIs are closer than those at the mall because they're more likely closer to the same level of fitness than those at the mall. Army recruits have, one way you can think of it is Army recruits, they actually have to pass the physical test so that they can, actually be in the Army. So their BMIs have to be around the same or close to each other, which is why their BMIs are actually closer to the mean than anything else. Now, people at the mall, they were actually more scattered and out, but because the Army recruits have, something that they have to, like the same amount of fitness, then they have to be around the same level of BMI. So, Skylar, can you describe which measures of center are usable for the Army recruits but not for the mall shoppers?
So for me, I think median and range would be good measures of center for the Army recruits because their data set is so much closer together from one another. Like if you saw the standard deviation is 3.6 something, and so that's just saying that like there's only like 3 in between each one. So like there's only 3 points in between each one, and so your median and your range are kind of just like they would be more precise than if you were going to use for the mall shoppers, because the mall shoppers, if you were going to use like median and range, it would be kind of all over the place because their BMIs are all over the place. So for the mall shoppers, you'd want to use standard deviation and the mean rather than median and range. And then, so what are the outliers and how does it change the distribution of data, Heather?
Okay, so first off, an outlier is a number in a data set that is more than 1.5 times the inner quartile range. And so that's below the lower quartile and above the upper quartile. So if you look at the random mall shoppers, that's the only one that has an actual outlier. There's not one over here in the Army recruits. So what it is that this 72.5 is so much further than any of the other data. So it's just up here all by itself. And because of that, it actually skews the data to where you can't do anything else from it. If it would have been 70, it wouldn't have been skewed. It would have still been in this range. And so it would have pulled it back down and you could have actually used the data. But because it's out here all by its lonesome, it is now skewed the data to where we can't use it anymore. But that is fine. Now we're going to go to measuring the center of and variation of data. It's still using more BMIs. And Tony, what is a standard deviation?
Okay, so a standard deviation is the amount of variation of a set of values around the mean. It's kind of like it's like calculating the miles in between each gas station on a road trip. So like however many miles it takes you to get to each gas station while you're getting to a certain destination. That's kind of like what your standard deviation would be like in a way. Heather, can you explain the meaning of the confidence interval for each set of data?
Okay, so for the confidence interval for each set of data is the percentage between the positive and negative second standard deviations. So you take the standard deviation and go to the left twice. And then from that, you would go back to the standard deviation, go to the right twice. So for this set of data for the American Women BMIs, your confidence interval is going to be 15.4% plus or minus 40%. And that's the same if you scroll down to the men. You're still taking the second standard deviation to the left and the second standard deviation to the right. And so it's going to be 19.5% plus or minus 38.5%. And we have Skylar. Can you explain the meaning of your Z-scores?
Yes, so a z-score, so how you would find a z-score is you would just take your x value, which if you look, it's, she actually has her data all set up, it's 3.1. So, and then you would subtract by the mean, which is 27.7, and then you would divide all of that by the standard deviation, which is 6.15. So that's how you would find your z-score. And then when you do that, your z-score actually turns out to be -4. And then if you were to look at your data under the bell curve, it shows you that your standard deviation for 3.14 is the -4 for standard deviation. So standard deviation and z-scores are actually the same thing. What is the probability of a healthy BMI score in your state, Heather?
So based off the research done back in 2018, I did it based off like ages 26 to 44, and it said the probability of having a good BMI score is actually 60%, because about a little over 40% are obese in Arkansas. So based off of that information, you're more likely going to have a better BMI score than some of the other ages in different states. Interesting information, by the way. But Tony, now can you explain the relationship between the average, standard deviation, z-score, and confidence intervals?
Yes. Okay, so the average, in other words, is actually our mean, which is 27.7, and our standard deviation, which is our 6.15, it is based on the distance from our mean. And then if you look at the z-score, it is the number of standard deviations a given point lies above or below the mean. So that's how the z-score works in with our mean, which is our average, and then our standard deviation. And then with confidence intervals, they are affected by the standard deviation, which is the width of the confidence interval. It actually increases as the standard deviation increases. So they actually all work together. Like if one changes, it affects the other. So that pretty much concludes our Team Teach number 2. This was Mod 2, Chapter 13. We'll see you next time.
Bye.
Bye.